and a very good afternoon to everyone, especially our Dr. Choon. My name is SITI ABDULLAH. My matric card number is CE 190250. So I'm going to talk about the introduction for our assignment. A cache is utilized by the central processing unit of computer to reduce the average time to access data from the main memory. The cache is smaller, faster memory which is stored duplicate of the data from as often as possible utilize main memory location. And a small block of high-speed memory called a cache between the main memory and the processor. Cache store the recently accessed data so that the future request for the particular data can be served faster. For your information, a CPU cache is a hardware cache used by the central processing unit, which is CPU, of a computer to reduce the average cost time, which is energy, to access data from the main memory. A cache is smaller, faster memory located closer to processor core, which stores copies from the data from frequently used main memory location. Most CPU have a hierarchy of multiple cache level L1, L2, often L3, and rarely even L4, with separate instructions specific and data specific cache at level 1. A cache where the cache location for a given address is determined from the middle address bits. The objective for our project is, to assign each of memory block into a specific line in the cache, not in arbitrary line, and to storing the total address information with data in cache. Only parts of address bits is stored along with the data. The scope of this project is we need to stimulate the direct mapped cache method using Paracache software. Initially, somehow, the block identification in direct mapped is important because each of block functionally as memory, and it also can be mapped at different time to a cache block. Each of cache block has a tag saying which block of memory is currently present in, and each it also contain a valid bit to ensure whether a memory block is the cache block currently. Okay, next is for methodology. As you can see, this is the flow chart for our methodology for this project. Okay, first is planning, second is analyze, third is design, fourth and last but not least is system. Okay, for planning phase, this phase is defining requests to investigate the problem in current situation, from the desire to perform additional tasks to the need find the information. The must be focused on the software. Paracache support for cache mapping scheme, which is direct mapped, fully associative, two-way set associative, and four-way to set associative. Memory address is broken down into three components, which is tag, index, and offset. Next is for analysis phase. In this phase, used to define the problem before the result is out from the software that we are using. If the input correct or has been set up, so the output given will completely fully from our desire. So we need to know each of the function what value is need to use to get correct value. Okay, next is design phase. This phase is basically to create or design the new circuit for the project and define the stable software that may use in this project. We need to understand more about the software that we are using so that it will give the correct output. Okay, next is software requirement. In this project, we are using Paracache software as our main software. Paracache is web-based platform to allow students flexibly access and explore the simulator in depth. Last but not least is system. The simulator provides user with interactive tutorials and simulation to help them better comprehend the fundamental concept of memory management. Paracache is implemented using HTML, assisted by CSS in styling and JavaScript in logic. The key goal of the web-based simulator is to summarize both the memory allocation efficiency along with its hardware implementation cost. This will enable the user to live throughout analysis and comparison of various cache mapping schemes supported by interactive graphical method. Okay, that's all from me. Thank you.
My name is HAKIM bin NADZRUDDIN. My matric number is DE 10136, and today I want to share the simulation for direct mapping cache. So first of all, we click the direct mapping cache, and then this is the cache size. power of 2, 16 power of 2, and memory size is power of 2. Same 2048 power of 2, and offset bit is 2. So we submit the 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 cache size, memory size, and offset bits, and then we put the instruction. So our group use this instruction, which is 3, 3, 4, B, 0, 7, A to A, C, and 5, and then we submit. Okay, this they said the instruction has been converted to from hexadecimal to binary and allocate tag, index, and offset respectively. So these input instructions are in hexadecimal and they are converted to binary. So our tag is 7 bit and index is 2 bit and offset is 2 bit. So first first instruction is 3. So press next. So the index request in yellow 0 0. So for the first line, first row. Okay, next. So the valid bit will obtain and analyze. We see the diagram, and the cache is missed. So cache is update with new data set. Okay, so cache table is updated accordingly for from block 0 with 0 offset to 3, transfer to cache. Okay, next is instruction is 3, submit. So the thing is repeated. No. And obtain value. So we see, okay, the cache is hit. So should look to the tag to 0 and request tag and cache tag is saved. So the cache is hit. Next. So cache is updated to block 0 with offset to 3 and transfer to cache. So we repeat the same thing with our instruction input. Submit. Next. So the index is 0 1. Next. So we see miss. Next. We transfer to index number 1. So we submit B. And the offset in the index is 1 0. 1 0 is 2. Next. Next. So we see the cache is missed. So block 2 will 0 to 3. Next. So we submit 0. The index is 0 and the bit is 1. Next. So the cache is hit. So we submit 7. The index is 0 1. So 0 1 is at this column, at this row. The cache is hit. Right, submit A. The cache is hit too. So we submit to A. The cache is missed. A, C. So C is the index is 1 1, which is at row number 3. Next. The cache is missed. And then we submit our last input instruction. So the index is 0 1, is at this row. So the cache is hit because the offset is 0 1. Right. After we done all these things, we want to see the hit rate and miss rate for our group. So we can see our input, which is 3, 3, 4, B, 0, 7, A to A, C, and 5. The statistic shown the hit rate is 50% and miss rate is 50%. So for load 3, first 3 is miss, load 3 for the second is hit, 4 miss, B miss, 0 hit, 7 hit, A hit, A2A miss, C miss, and 5 hit. So that's all for our simulation part. Thank you.
Good evening, doctor. My name is MAHAD AHMED. My math number is PE 190022. Today I'm going to present a discussion for our project. So firstly, the significance of what we have tried to acquire in this project is through getting the right result delivery, which is hit or miss. It allows user to see and have a better knowledge of the basic idea of memory management. Another feature that distinguishes Paracache from other simulators is the ability to simulate store instruction utilizing write-back and write-through techniques. In the write-through approach, the data is instantaneously updated in the cache and memory block. When a block in cache is replaced, write-back will only update the main memory, leaving a brief information gap between the cache and main memory. Write-back is more efficient since it does not require access to main memory every time data is modified. When a write miss occurs and the requested address to be written is not currently accessible in the cache, there are two processes to handle the situation. This table shows the result from our simulation. So the input and output data from hexadecimal to binary numbers are shown in the table above. In our project, we have set the value for cache size, which is 16, and assume memory size is 2048, and offset bit is around 4 bits of the size. The number for the following instruction is assumed to be the input for the programming. We were utilizing a character string of at least 9 characters, which is 34B07A2AC5. Because the number is initially in hexadecimal, the program will convert it to binary. That's all. Thank you, Doctor. Today I'm going to present a conclusion for our project. So finally, a cache is a hardware or software component that saves data so that subsequent requests for that data may be served more rapidly. As for the project goal, we were able to allocate each memory block to a specified line in the cache rather than any arbitrary line. And we're also able to save the whole address information with the data in cache. However, only a portion of the address bits were stored. In general, the predicted outcomes that we specified are the same as what we analyzed in the simulation results. In comparison to the associated cache mapping, direct mapping cache is less costly. However, due to the constraint, the performance of the direct mapping cache is poor since it requires data tag value replacement. As a result, direct mapping cache is the most advantageous and straightforward method of memory mapping. Using MCD RAM cache to improve the performance of direct mapping cache is suggested. The last one, because the MCD RAM cache is a helpful tool for the increasing memory bandwidth. This is the case. It can act as a memory side cache for recently utilized data and provides significantly more bandwidth than DDR memory. When MCD RAM is used as a cache, it is a direct map cache. This means that a single cache site is shared by numerous memory locations. As a result, time on the MCD RAM cache for a programming is a simple first step. That's for all, Doctor. Thank you.